So you can't really taste what makes water suited for brewing. And even if you could, the goalposts move every time you brew. And of course, there is a wide spectrum of beer, and you do want to brew them, right? So to do that, you have to learn how to work with your water. So I'm going to hopefully help you understand a little bit more and therefore be able to do this. So why do you care about water? Well, it's the major component of beer, and it affects every other component of beer. So let's look at all those components and what those effects are. Of course, you got the malt, the hops, the yeast. Let's look at each component. So first, the malt. A high pH or a high mashing pH extracts tannins and silicates from the grain husk, and those are not exactly very good tasting items, so you definitely want to try and keep them out of your beer. High pH also impedes starch conversion, so you do want that to go properly so that you're actually producing sugars instead of just leaving your beer all starchy. High pH certainly dulls beer flavor. That's probably, in my almost 21, 22 years of judging, that's probably one of the biggest things that's a bellwether of improper pH is you got a really dull tasting beer, and it isn't right. And then one other item, and this shows up especially for the paler beers like Wits and Hefeweizens. If they turn out darker than expected or than what you're used to seeing, well, more than likely pH, high pH, had a factor in there. Let's look at hops. Well, again, high pH extracts polyphenols, which are in essence the kind of the green tasting elements of hops. It's like a tea. You don't want them in your beer. The other thing that it does is it creates a harsh bitterness in your beer. So that's something that you really want. You want the finer hop bitterness and none of the harshness. So avoid the high pH. And then ultimately, a high pH alters hop flavor, which obviously you don't want. And then looking at the yeast, high pH interferes with flocculation. The yeast flocculate and settle based on the pH of the beer in which they're floating. High pH tends to keep them from flocculating, so it's not a good thing. And then, as you know, one of the protection mechanisms in beer is the acidification that yeast provide. And well, if you're starting at a very high pH with your wort, your yeast are going to have to work extra hard, and your wort is going to be at a higher than desirable pH for a longer period of time. And lo and behold, spoiling organisms can gain a better foothold and affect beer flavor. So that's a real killer. Okay, so care about your water because it affects everything in your beer. So brewing has two main concerns: your pH, the wort pH, and then the mineral content of the actual water. And I should say that's the wort pH, not the water pH. Water pH is not an important thing. So wort and mashing pH should always be targeted. The proper range is typically in the range of 5.2 to 5.8. I like to tighten that up a little bit. Generally 5.3 to about 5.6 is a good range. Most pale beers, you're going to be down in the 5.3, 5.4 range. The darker beers like porters and stouts, you definitely want them higher in the 5.5 to 5.6 range in order to help avoid some of that acrid roast flavor. The higher pH, just like, so there's a process called Dutching of chocolate where they actually add an alkali to the chocolate and it makes the chocolate flavors much more rich. And I do the same thing when I brew my coffee, adding a little bit of sodium bicarbonate to my RO brewing water, coffee brewing water that is, actually does make the coffee flavors a little bit fuller, and it reduces the acrid bite to that roast flavor. So it's a really good technique. And for you brewing, porters and stouts, you should do the same. 5.5, 5.6, that's a good range for those beers. So one of the reasons why brewing is kind of tough. So looking at this map, this shows the alkalinity of surface waters across the U.S. And interestingly enough, the worst water is this very pale yellow, of which Indiana thoroughly occupies. Unfortunately, they don't show Bloomington, which actually has beautiful water. But you'll notice these mountainous areas, like the Rocky Mountains, and here are the Appalachians and the great New England. They actually have very low or lower alkalinity that's a little bit easier to contend with. But the whole point of this slide is that, hey, just about all water everywhere seems to have a lot of alkalinity, and alkalinity is the number one thing that you need to be concerning yourself with when brewing. So, and because of that alkalinity, that means that all brewing requires an acid of some form. So let's look at the various forms that we can achieve that. Well, the first thing, and I think that many of you know that roasty beers, dark porters and stouts, because of the roast malt content, roast malts tend to be very acidic. They will consume that alkalinity, and that's one of the reasons why dark beers were very successful in places like Ireland and even Munich, because the water there is very alkaline. Some of you may not know that crystal malts are also kind of acidic, more acidic than a regular base malt, even when they are a pale color, like as shown here. So crystal malts and roast malts add acidity, a good thing when you're dealing with an alkaline source water. Another way to produce enough acid is to add calcium and magnesium salts. They, through a chemical reaction with the phytins in the malt, they actually produce an acid, which then neutralizes the alkalinity of the water. And then finally, just adding a liquid acid like lactic acid or phosphoric acid. Those simple additions can neutralize alkalinity and allow wort pH to go where you want it to go, which is low. And on a allied note, a typical pale malt or Pils malt grist without any crystal or roast or anything like that, you mash that up in say RO water or distilled water. The pH of that wort is only going to be in the roughly 5.8 range, and 5.8, remember, that could be maybe good for a very roasty dark beer, but it isn't worth a crap for a pale beer. So getting that pH, the wort pH, down into the proper range requires that acid addition. So all brewing water needs treatment. Some just need it more than others. So I mentioned RO and distilled water, and as I cited, even with a Pils malt, you're still going to require some treatment. You're going to need some acidification of some form in order to get the pH into the proper range. So just switching from tap water to RO water or distilled water, it's still not enough. And for you extract brewers out there, of course, all the minerals are already in the extract. And when they created that extract, all they did was drive off the distilled water. And you actually do want to just add that distilled water back. So RO or distilled water are best when brewing extract brews. And for you brewing a baggers or no spargers, yeah, you still have to treat your water. There's no avoiding it. It will affect your beer. Now, a lot of people say, oh, well, the early brewers didn't worry about water. Well, yeah, they did. You just didn't know, you may not understand what they did to do it. So let's talk about some of those methods. Pre-boiling, for instance, the water here in Indiana, as I pointed out in that slide, very alkaline. It's also very hard. It turns out that combination is called temporary hardness. And by pre-boiling the water, you can drive off the alkalinity and get all the chalk in that water or most of the chalk to actually precipitate out a solution. And as soon as that boiled water cools and it settles down to the bottom of the kettle, you can decant off the clear water and brew with that clear water, and it's much better than with the tap water. So that was one method, and that's been practiced for hundreds of years. Lime softening is sort of the same as pre-boiling. It's causing the alkalinity to drop out or actually causing the chalk to drop out, and thus reducing the overall alkalinity of the resulting water. And again, you let it clear, and then you decant it off, and voila, you've got something good to go with. In Germany, acid rests were very common. Of course, if you dough in your mash and you let it sit at roughly 100 degrees Fahrenheit for, say, an hour or so, you will create acids because, of course, the grain is coated with lactobacillus, and that will knock out alkalinity. Same thing is practiced with acid malt. Acid malt is just coated with lactic acid, or in true German maltsters practice, it's actually covered with sauergut, which is lactic soured wort. So yes, old brewers did do water treatment methods. So how should you treat? Well, it's really not that difficult, but how do you do it? Well, you need to find out what's in your water. For Indianapolis and all the various cities around us, typically you can call the water quality lab at the water company that supplies your water, and they may or may not be able to tell you most of the parameters that you need for water calculations. But if not, of course, there's Ward Labs. So water company report, you have test lab reports, and then you can also do home testing. And by home testing, I'm talking about aquarium test kits. These are cheap. They only provide a couple of parameters reliably. The most important are how hard the water is. And by that, I mean how much calcium's in the water. And then the other most important item is the carbonate hardness, or what it truly is the alkalinity. So that KH bottle there, that's actually an alkalinity test kit. So with just those two simple tests, you can get 90% of the way to being able to properly calculate how a mash is going to end up. So in getting the pH right. So what next? Well, let's talk about Indy water. So I reviewed a bunch of Indy area water reports provided by a number of FBI members, and I was able to deduce some somewhat broad parameters that reflect typical tap water characteristics in our Indy region. 67 parts per million calcium. That's fairly hard. 20 parts per million magnesium. That's getting on up there for magnesium. You wouldn't want more than maybe twice that, and the magnesium content is actually going to be too much to brew with. The 26 parts per million sodium is really not that bad. That's nothing to be concerned with. The 75 parts per million sulfate is a touch high. There are some beer styles that you may not want that much sulfate in, so that's a little bit of a concern. The chloride content of 47 parts per million, really not that bad at all. Honestly, you might want roughly that much chloride in just about any beer you're going to brew. But the real pusher here is the bicarbonate content at 225 parts per million. That is way too high, and that requires definite attention.
Martin,
And Aiden, please.
I have. Part of this on my other screen. I have a recent Ward Labs report, and I've got to say that Westfield water kicks Indy's water's ass.
This one here.
I mean, everything you see here, we've probably got at least 50% higher. Calcium, 101 parts per million. Magnesium, 30 parts per million. Sodium is 21, we're a little lower there. But basically my point is, if you live in northern Hamilton County, it's much worse than this.
Thanks, Charlie. Okay, so bottom line is Indy region water is not horrible, but the alkalinity is really breathtaking, and it must be attended to. So what, now that you know that, what do you do next? And my recommendation is that you should use a calculator to guide your water additions. Water chemistry, it's not exactly easy, but it doesn't have to be that hard. So let's look at a couple of options for you. Bru'N Water is one method. And even though it looks complicated, if you spend a few minutes reading the instructions, you literally can't just start using Brewing Water. You actually have to read the instructions. So, sorry, water chemistry is not easy, and you actually have to learn something. I realize that's kind of hair pulling, but too bad. So, there are so many water programs out there that literally get you going, and they don't even tell you if the water report that you're putting in is proper. So there's an old axiom in computer engineering, garbage in equals garbage out. And for most of those programs, yeah, you're dealing with garbage. With Bru'N Water, we're trying to keep you from putting garbage in and getting the proper result out. So a lot of you want simple, and that's understandable. So let's look at some real simple options here to if you're a little bit leery of dealing with the program or what that that sort of thing. Well, there are still rules of thumb that I have created here for indie water that I think can help you out a bunch. So let's look at them. So the first thing that you have to do whenever you're dealing with municipal tap water is to remove the chlorine or chloramines from the water, because they will create chlorophenols, that Band-Aid flavor in your beer, and adding 1 Camden tablet at the rate of 1 per 20 gallons of water will knock out all of those chlorine and chloramine compounds and at least remove that off flavor from your beer. And because many of the water supplies in the Indy area do include chloramines, carbon filtration can be very tough to do. For the typical 10-inch filter, which is the big canister, big one, to remove chloramines from the water, you would be looking at roughly 1/10 of a gallon per minute in order to effectively remove all the chloramines. Now, here in Carmel, they use chlorine with no chloramines. You could actually bump that up to 1 gallon per minute, but you can see that it's still pretty slow. So you're going to be spending time. That's one of the beauties of dealing with the Camden tablet, aka sodium metabisulfite. It knocks out the chlorine and chloramines very quickly. So that might be a better option for a lot of folks. Okay, so looking more at simple treatments for pale colored beers. 1.2 milliliters of 88% lactic acid per gallon in your mashing water. And even sparging water does require the lactic acid too, at a rate of roughly 1 milliliter per gallon. And a word of caution here. So this is with 88% lactic. Lactic acid definitely has a flavor. We here should be, unless you're a super taster, most people will not taste it at 1 to 1.2 milliliters per gallon, but most people will taste it by the time you're adding lactic acid at a rate of roughly 1.5 milliliters per gallon. So, for some people, it may not be your cup of tea, and for that reason, you might want to go to phosphoric acid. So for dark beers, okay, I've already mentioned, we've got a lot of alkalinity, but of course with a dark beer, you're adding roasted malts that have a lot of acidity, and more than likely, you won't have to actually add any acid to the mashing water, but you still have to acidify the sparging water. And again, it's the same dose, 1 milliliter per gallon, and you shouldn't really be able to taste it, and you should be fine. Now let's look at some of the mineral adjustments that some might consider, and these are kind of namby-pamby, middle of the road, nothing special, not a pale ale kind of thing, just a minor bump in a direction, in the proper direction, for something like, in this case, a hoppy beer. An 1/8 teaspoon of gypsum in each gallon of mashing and sparging water is going to add, I want to say, I think that was roughly 100 parts per million sulfate. And of course, remember that the water in this region has, a little bit of gypsum. So, I'm sorry, a little bit of sulfate already in there. So, if you're brewing a pale ale, you might be adding more than this 1/8 of a teaspoon, but it's good for many beers. In a malty beer, well, here you want to increase the chloride content because that improves the fullness of the beer and makes the malt a little more, I guess, mouth coating, I would call it. That's why I a lot of people like to consider that sulfate makes beer bitter and chloride makes beer malty. Well, that's not true. Sulfate makes beer dry and chloride makes beer full. So by full, that means it coats your mouth and leaves the malt in contact with your taste buds for far longer. And for these malty beers, adding roughly 1/16 of a teaspoon of calcium chloride for each gallon of mashing and sparging water will provide a noticeable difference in the resulting beer. And of course, if you're aiming for a malty or a fuller flavored beer, well, that's the kind of thing that you would do. So, I was throwing numbers out at you, as approximations. But the bottom line is that these mineral additions can be approximate, and you don't have to, get them dialed into the gnat's ass. You can deal with, being close, hand grenades and horseshoes is the message here. So, get it close. It will make an improvement. When you feel that you need to take it to the next level, that's when you pull out one of those brewing water programs and you start looking at what those additions are actually doing. So the simple adjustments can make the big difference in your beers. Now, and of course, how to make poor beers, use crappy malt, stale hops, sick yeast, but, using untreated water and you're going to have a poor water or poor beer too. So there are many ways to get to a poor product, but I think there's another reason why you're here tonight. So even good tasting water can send your beer quality down the drain. So with that, let's have some questions.
Martin, I want to go back to where the questions I had about chlorine and charcoal, where I was starting to ask earlier, because I'm very concerned about sometimes I detect some phenols in Westfield. And
sure.
So I'm very, very concerned about, and that's why I was kind of focused on that in my questions. And you were talking about charcoal filtering. Now we use RO, but we blend Westfield water back in with our RO because the Westfield water has some very good characteristics in it. It's just way too many parts per million of everything. But when we do about 75% RO and 25% Westfield, we get a pretty nice water. But I still am very concerned about chloride. And so we charcoal filter everything. The RO, we don't have to worry too much about any chloride, obviously, or chlorine in the charcoal, excuse me. But I am very concerned about any possible chlorine coming from the Westfield water. And is charcoal filtering sufficient?
Well, it depends on your filter system. If it's the typical, 10 or 20 inch carbon units, it's probably way insufficient. I mean, for the breweries that I consult for, we're talking about charcoal or activated carbon canisters that are hundreds of gallons in capacity. So I don't know what your flow rate is, but that'll make a difference.
So it would be smart for us to add the Camden tablets regardless.
Maybe. But the other option is to make sure that your carbon system is properly sized and that you're not flowing too fast through the carbon. There has to be a certain length of contact time for those contaminants to actually be effectively removed.
Excellent. That's telling me a lot. I mean, seriously, we do not have much of a problem with phenols, but every now and then I will detect a phenol, and that's my belief is that we're getting some chloride coming through, and that's causing the phenol.
It could very well be. Okay, and let's see. Any other questions?
Martin, just kind of follow up on Charlie's question. After he runs through his carbon filter, is there a way that he can test to make sure he's removed all the chloramines?
Oh, actually, yes. So a simple swimming pool test kit that tests for total chlorine will provide you the kind of knowledge and assurance that your filtered water is actually filtered. So I recommend the liquid ones where the water turns yellow when you're in the little vial. They are very effective. They will be able to tell you pretty reliably down to damn near zero. And with chlorine and chloramines removal, you really have to be at zero, because I think the taste threshold for chlorophenols are in the less than a part per billion range. So it takes very little, and the chlorine and chloramines are coming into your house at roughly 3 parts per million, which is 1,000. So that's 3,000 parts per billion. You really have to take it out. So you have to get extremely high removal in order to make sure that you're not going to end up with chlorophenols in your end products.
Andrew just brought up the point there on the text chat about smoke beers.
Well, that's true. Yeah, and
I want chloroseptic.
and they will throw off the flavor. Next question. So is there any interest in actually getting a preview or introduction to Bru'N Water? We still have probably a good 15, 20 minutes.
Absolutely.
Yeah, I use Bru'N Water a lot, and I've got to say, because I've also used Easy Water Calculator and Bru'N Water, and there's just no comparison. If you're really interested in your water, a Martin spreadsheet gives you a ton of information.
So let's take a quick look at this. So the first thing, of course, is, okay, there we go, is you have no choice. Bru'N Water is a complicated program, and it takes just, I'd say, 10 minutes of reading to actually understand, okay, what am I doing? Why am I putting this here? What am I putting where? and moving on. So yeah, you actually have to read instructions. I know for a lot of people, that's a tough one, but it's not a killer. You will be richly rewarded. So some real broad analysis here. So know what's in your water and input that data. Sometimes that's kind of tough because if you have something other than like a Ward Labs water report, sometimes the data that your local water supplier is giving you, it's Greek, so it's understandable. But there are converters to help out with that in Bru'N Water that hopefully get you to the true answer. So you put in the water data, then something says, hey, something's wrong. It's not balancing because anions and cations are supposed to balance. They do actually balance in water, but your water report inputs don't come out right. Well, then you got to figure out what's wrong, and it's another head scratcher. But this is a reason why Bru'N Water is a million times better than virtually any other program, because all those other programs skip this step entirely. They'll let you put in dog shit, and guess what you're going to get out of your calculations. So, you got to get the inputs right. Next item, you're going to figure out how much acid to add to the sparging water. And then you're going to select, input your grain bill, and then select the water profile, and then start trial and error. And you're looking at your difference between where your water is now and where you want it to be, and you say, oh well, I need some more sulfate, and then you look at the sulfate containing minerals, and you add a little bit here, and well, does that get you close enough? Well, no. Add a little bit more. Where does that take my pH? Do I need to add some acid? So with a little bit of understanding of what does what, it turns out that really it's pretty damn quick. I can be in and out in about 2 or 3 minutes once I've got my grain bill input. So water report input, the main things are calcium, magnesium, sodium, the bicarbonate content, which is the alkalinity, the sulfate, and the chloride content. With those 6 parameters, pretty much you've got everything you need. And hopefully, with the free version of Bru'N Water, it's not going to give you this kind of precision. It just has a general note up here that says, oh, your water report is not balanced. So yeah, sorry. I didn't want to get it too complicated for the free guys, so that they would be able to hopefully get something done quickly and not get bogged down in the details. But there are converters down here that, if your water company is giving you results in some, strange unit, hopefully I've got something in here that actually allows you to convert it to something that can actually be used up here in Bru'N Water. So once you've done that for your water, you're good. You're probably never going to come back to this page again. Then you go to the sparge acidification page, and you've got this, in our area, we would have a huge amount of alkalinity. This would be red. And, you need to add some acid. And of course, you can add a variety of acids depending on what you've actually got on hand. Phosphoric acid, lactic acid, maybe even citric or hydrochloric acid. But, those sorts of things are